This is the Building Automation Monthly Podcast with Phil Zito, episode 181. Hey folks, Phil Zito here, and welcome to the Building Automation Monthly Podcast. And in this episode, we will be talking through a deep dive into virtual servers. Now, I know we've talked about servers in the past. We've talked about client-server architecture, but we've never done a really deep dive on virtualization and virtual servers and what exactly they mean to you. Now, this is a really important topic for any of you who are utilizing servers on your building automation projects. At the end of the episode, we'll talk through 3 ways in which you can utilize building automation servers and primarily virtualization with those servers in order to really optimize how you do your building automation work. As always, our Building Automation Monthly podcast is sponsored by our courses, and this week's episode is sponsored by our Information Technology for BAS Professionals. Now, as all of you know, going and dealing with IP controls, analytics, IoT, APIs, databases, Haystack, all of that fun IT stuff is quite difficult if you haven't been trained on IT. But what are your options? You can go do a Network Plus course, but that's only going to teach you networking, and it's going to teach you a lot about networking for IT. But what about BAS networking? What about BAS servers? What about BAS databases? What about troubleshooting BAS devices and common BAS IT issues? Man, talk about a mouthful of acronyms. Well, if you need a course that is focused on teaching you IT, but only what you need to know for your BAS career so that you can go and execute your BAS work and never get delayed by an IT department or hung up on an IT issue ever again, well, then our Information Technology for Building Automation Professionals is the course for you. This fully online course will teach you everything you need to know about IT and will ensure that you are future-proofing your career no matter what IT concept comes up on your BAS projects in the future. I encourage you to learn more about this course by going to buildingautomationmonthly.com/181. Scroll down, click on the IT for BAS Professionals logo, and find out more of the course. All right, folks. So virtualization, virtual servers, what is all this craziness? Well, virtualization, my friends, is nothing more than taking a physical device and creating a virtual version of it. So for example, let's say you have a hard drive, right? A hard drive. We all know what those are, right? They store data for our computers. Well, let's say you have a hard drive and it's a single hard drive. And what you can do with virtualization is you can actually take a virtual software solution and divide out that hard drive. And you can make multiple versions of that hard drive. That way, folks are accessing portions. I like to refer to virtualization as timeshares for computers. What we are often doing is we are slicing up a portion of a whole. So, a timeshare, right? You have a whole house or a whole condo, and you're slicing up time slots that folks can then utilize over the period of a year. Well, virtualization is no different, right? We're taking CPU, processing power, we're taking storage, and we're also taking memory, and we're dividing that up and enabling multiple computers or virtual computers to utilize those resources. So then what's a virtual server? Well, a virtual server quite simply is a server that is using that concept of virtualization. So rather than dealing with a server, a single blade server or rack mount server or, desktop looking server, instead of dealing with a physical server, which you're actually often dealing with, is some sort of computer that is sitting off in a data closet somewhere and is actually instantiating, so it's initiating a operating system and utilizing a certain portion of that computer's CPU, memory, and storage in order to simulate a server. It's a virtual server. Now, virtualization, when we're talking about especially OS virtualization, utilizes this thing called a hypervisor. And basically, it's like a supervisor for the memory, OS, storage, and processing virtualization management. So there's really two types of hypervisors. There's type 1 and type 2. Now, type 1 is going to be what you're seeing in large-scale enterprise applications. This is where this software, it's sitting on this machine. And rather than this machine having an operating system and then running virtualization software, which any of you who've used VMware, Oracle VirtualBox, or Hyper-V on Windows Server, you know that you run this software and then you build a virtual disk and then you run that virtual disk and you install an operating system on it. Well, that's not what type 1 is. Type 1 is actually running no operating system. It's running this software that's sitting there raw on this server, and then the software actually instantiates multiple operating systems. So you'll see this often used for large-scale enterprise applications that need security, or if you're doing large-scale desktop replication, you can see that happening as well, things like that. Type 2, however, is you've got an operating system installed, either a Windows 10 or Server 2000, whatever it is at the time of this recording, and you're running, VMware, you're running Oracle Box, you're running Hyper-V, and those are actually instantiating virtual disks and instantiating multiple operating systems. Now, there's pros and cons to each one of these, right? So hypervisor type 1 is going to be really fast. And if you've got an enterprise server, it's what I recommend you utilize. Now, enterprise server, what does that mean? I'm talking hundreds of buildings. I'm talking like GSA, right? Or a massive college campus, things like that. This is not going to be the type of virtualization you're going to run for a 5-school school district. That would be type 2. Now, obviously type 1, it's going to be more expensive. It's going to be more technically complicated. It's going to require more technical capabilities. And it's just, all in all, it's more difficult to deal with. But it's freaking fast and it's super secure, because you don't have a operating system between it and your virtual machines that can be corrupted and have all sorts of security issues. Type 2 is much easier to use. It's often very graphically driven, super easy to use. If you've never looked at VMware or looked at Oracle Box, they're super easy to use. Check out Oracle Box. It's free. I'll put a link to it at the end of the little show notes at buildingautomationmonthly.com/181. All right, so as I mentioned, type 2, you use an operating system, then you have this software that's running the virtualization, and then you go and instantiate virtual drives, and then you load those virtual drives, and then you go and install the OS on the virtual drives. So why would you even want to go through all this hassle, right? Why go through utilizing virtual server? Well, there's 4 really big reasons why you want to be utilizing a virtual server, all right? And these are really important. First is recovery. Have you ever had a server die on you? It freaking sucks, right? And then you're trying to go and stand up that server and you're like, oh, it's not a big deal. I'm just going to take the hard drive and swap it to another computer. And then all the drivers are mismatched and it's corrupted and you're getting blue screens. It's just ugly, right? Well, what if when your server failed, another server started up auto-magically? It just automatically started up working right away. Automagically is not a real word, by the way. So yes, for those of you who every week send me grammar corrections, I know automagically is not a word. All right, but for the rest of you, it's going to automagically recover the server and stand it back up. And so you will then experience almost no downtime, which leads to our next benefit, which is uptime. If you want a server to be constantly up and you want to ensure that, hey, if a hard drive fails or whatever for this critical BAS server, we want it up. Well, guess what? Virtualization is going to have your back there as well. Load sharing, which directly ties to a concept called elasticity. So load sharing is awesome if we are utilizing a server and we're using it for complex analytics, or we've got multiple graphics hosted on it, and we're going to have dozens and dozens of people logging into it. That could really start to wear on the server. That can start to create a lot of client session requests over HTTP. That can cause all sorts of resource accessing concerns. It can just bog down a server. It's basically like if that guy was logged into the server directly, playing solitaire on it and slowing it down. Well, the beauty of virtualization is that with load sharing and elasticity, we can go and increase the CPU capacity of the server on demand, or heck, we can do it automatically without even having to go and do anything by just setting load and elasticity thresholds. So we say once we're at 90% CPU utilization for a certain period of time, well, guess what? We stand up another CPU core. And that allows us to real quickly go and expand the capacity of our servers. So we're never going to run into a scenario where their servers are running super slow because we're using that load sharing and elasticity, because we can share the load across multiple physical machines, and we can stand up multiple sources of memory, CPU, and storage as necessary. This is why cloud is such a big deal, because this is the model that is utilized for a lot of cloud servers. They're elastic, and as your capacity demands increase, well, guess what? It's going to expand with you. So how do you set this up, right? How do you go and make sure that your virtual server's working for you? Well, now I'm going to give you a couple steps on how you can do this, and we're going to walk through this, all right? So stick with me here because this is going to be really important. So how do we how do we set up a virtual server? Well, first we have to decide on our hypervisor. Now, as I went through the pros and cons of hypervisors earlier, you may have forgotten it though. So type 1, right? This is really fast, really secure, and it also requires more technical capabilities because it's often running without an OS. Type 2, less secure, real easy to set up, not as fast, but like did I mention, real easy to set up. So we need to pick which type of hypervisor and associated software we want to run. Next, we have to get the environment set up, okay? So if you're type 1 hypervisor, then all you really have to worry about is getting your network set up, making sure the CPU is running, and making sure that you've got the right amount of memory and storage. If you're a type 2 hypervisor, not hypervisor, I want to say supervisor every time I read hypervisor, and every time I think hypervisor, but it's not a supervisor. So if you're utilizing a type 2 hypervisor, then you also have to set up the network and CPU and all the hardware, memory, storage, etc. But you also have to set up the operating system, okay? So you got to make sure that that is running and any patches associated. So once you've done this, once you've got everything set up with this type 2 or type 1, you're going to take a snapshot. Snapshot is going to be an image of the environment, make sure everything's working. Now, obviously, if you're doing a type 2 hypervisor, you're not going to be taking a snapshot of anything because you're not even running anything yet. So, got everything set up. We're all good. Now we move into step 3, which is setting up our BAS software. Now here we go through the checklist of making sure our databases are all working, our BAS software is working, it's connected, we're connecting to our supervisory devices, we're pulling points, we're able to access the graphics, everything is good. Once all of that is done, then and only then will we take a snapshot of that machine. So we're going to take a snapshot of that machine and we're going to have this BAS server configured and running and doing exactly what we need it to do. And now we would go and set up any additional things like our failover, our elasticity parameters, anything we need to do there. But in most cases, you're fine just setting up your software and taking a snapshot and then just reloading that snapshot if something were to fail. But there are some advanced things you can do with virtualization. The first is failover strategies. So let's say the server, the physical server that is running that BAS server or BAS virtual server fails. Well, you can actually set up heartbeats between two physical servers, and this will go and detect that the one physical server died, and it will stand up the VM that you were running off of a centralized image on a third server automatically. And so you will have almost instantaneous failover, and it will be running at the same IP address. Everything will be running perfectly. The next is patching strategies. So oftentimes one of our concerns is that if we're going to patch a server, we have to take the server down. Well, that's the beauty about virtualization, in that you can have a production environment and a test environment. And what you can do is you can actually patch your server in the test environment. And once you are verified that the server is working, it's communicating, everything's good, then you can switch it over to the production environment, which your day-to-day users are utilizing, and that will have seamless transition. So you won't be having issues with having a server down. And if something happens where the server is no longer working, you can simply utilize rollbacks and just roll right back to the production server. Actually, you won't even have to do that because the production server won't have been switched over. You'll still be doing that on tests, so you can just abandon the patching. So that is the beauty of using virtualization when you're patching. And finally, and this is something I'm shocked that more BAS contractors do not implement, which is imaging. So you go through all this work, you set up this BAS server, it's all configured, everything's beautiful, clouds have parted, the birds are singing, the sky's blue, everything's great. And then you say, forget it, I'm going to go to my next site and do this all over again. And I'm going to go to my next site and do it all over again. Why? The beauty of imaging and snapshots are that once you've configured everything, you take a snapshot, and guess what? You use that snapshot on every single job you go to. And yeah, sure, you may have to put a different certificate and you may have to license the software again, because obviously you can't use the same license for every job. But the beauty is that now by imaging this, you have substantially reduced. I mean, seriously, folks, if you implement this one little tip right here, which is imaging instances of your servers and then standing them up across jobs, this is going to save you several days worth of work. I'm telling you, folks, that if you're not doing this, you need to. It's going to save you so much money. So make sure that you're taking images and snapshots of implemented servers, keeping them in a library. You can have like a version 4 server for your software, version 4.1 for your software, 4.8 for your software, and you just stand up these images accordingly. It's really a beautiful thing. So there you have it, folks. I wanted to do an overview of virtualization, virtual servers, because I've been getting a lot of questions about virtualization, virtual servers. And I'm sure you have some questions about virtualization and virtual servers. You know what to do. Go into the comments section. If you're watching this on YouTube, hey, go to the discussions. If you're watching this on our site or listening to it, go to buildingautomationmonthly.com/181. Drop your questions in the comment section there. I'd love to answer them for you. And as always, continue to learn, continue to develop yourself. And I look forward to talking to all of you again next week. Take care. Thanks a ton.